This is stolen from Nancy. Nancy, credit to you. To be fair, I think Nancy, I think you let all of the AP world use this. So, so I kind of stole from AP, who stole from you. But anyway, the idea is we want to draw a slope field of the following. Okay, and so what we're given here is it says dy over dx is equal to x plus 1. What this means, in other words, is that the derivative f prime of x is equal to x plus 1. And so this tells us kind of slopes that exist. This is a truly AP topic. This is not a Calculus 1 topic, so I never learned this until I started preparing for the AP exam. But this is not too difficult. All we need to do is plug in a point and use it to determine the slope and then sketch the slope. So watch. If I use the point 0, 0, it says to determine the slope, I plug in what for x? I plug in 0 because the x value is 0. You see that? So what's 0 plus 1? So what I do is at 0, 0, I make just a sketch of a segment that has a slope of about 1. Then I move on to another one. Okay, I'll go to the point 0, 1. What do I plug in for x? 0. So what's the slope going to be? Yeah. Then I'll plug in another point. I'll plug in 0, 2. And I plug in 0, so I get 1 again. So everybody see that x is equal to 0 along this line here? So what are all the slopes going to be? 1. Let's move back. Let's move to the left. What are all the x values here? -1. So if you plug in -1, what are you going to get? So therefore, you're going to get a slope of 0 at all those spots. Let's move to the right a unit. Okay, so I'm going to move over here. What's the x value here? 1. So what's the slope going to be? 2. So just kind of try to draw a little bit steeper than your first one. I'll continue to move to the right. The x value is 2, so the slope's going to be 3. So the AP exam will not be real critical. You can see that this is a free response type question. They're not going to be real critical, but they want your zeros to be 0. You know what I mean? Like they should be able to tell that. And obviously this won't be 4, so just make some steep sketches there. So that would be more than sufficient. They'd be very happy with a slope field like that. I'll move back the other way. What's the x value here? -2 is the x value, so therefore the slope's going to be -1. So I've got -1 going on. Yep. And then -2. Okay, so Colin sees something, and so we're going to talk about what he sees. So the slope field is interesting because if we look at it, it can actually produce the original function. So let's just think about it, for example. If f prime of x is x plus 1, does anybody know what f of x would be? The original function? That would be the antiderivative, right? What's the antiderivative of that? Plus x plus some constant, right? What, over 2? Yeah, x squared over 2 plus x plus some constant, right? And that constant will make it shift up or down, correct? So the fact is that, as he said, there's like a bunch of parabolas. Notice the slope field, it looks like a parabola would fit nicely in there, right? We just don't know if it's there or there because we don't know what C would be. You see what I'm saying? So this is not the graph that's produced. The antiderivative of this is the graph that's produced. Do you see that? So AP likes this topic because it connects derivatives and antiderivatives together. But sketching the slope field is our goal for the day. Should be pretty straightforward. The second one's a little bit different. It says 2y. Notice how we were able to see some patterns develop here, like it was going to be 0 right here, right? See if you could go ahead with a partner, come up with a quick sketch of 2y. Think about what parts might be positive, what parts might be negative, and take a quick sketch. Go ahead, take about a minute. Go ahead. Okay, so let's talk about this as we make it through. I'm going to look at, I'll just start by looking at this axis right here, okay? All right, what's the y value here? So the slope would be 0. What's the y value here? 1, so the slope would be 2. What's the y value here? So the slope would be 4. Y value here? So the slope would be -2, -4, right? In fact, the y value is 0 for all of these, right? So you should have slopes like this all the way across. And then here, the y value is 1, so you should have slopes of 2 all the way across there. Slopes of 4 all the way up here. And then I should see that these are negative down here. I should see that these are a steeper negative down there. So we should see something like that. Okay, see that? So same idea. See if you can think of number 4. Try to think if you can think of where it's going to be 0 and try to do it kind of quick. Okay, go. Okay, so x is 0 all on here, right? So it looks like you should have slopes of 0 all on there. And then you have x values of 1 here, so slope should be 2 there and -2 behind. 4 here, -4 behind. 6 here, -6 behind. So, you know, on the AP exam, they'd be looking to make sure you got 0 in the middle and then positives over here and negatives over there. How's that? Good? Yeah. Because the x value is 0, so therefore it's going to be flat line there. I'd like to go to number 5 first, okay? And then we're going to go back up to 4, y minus 1. So tell me, if I'm trying to do this efficiently, what value might you look for right away? So you're looking for where you're going to get a slope of 0. When would the slope be 0? Whenever y is, where is y1? Where is y1? Up 1, right? Everywhere here, y is 1. Agreed? So we're going to have zeros all the way across there. How about up here? Y is 2, so therefore the slope will be 1 all the way across. The y value along the x-axis is 0, so the slope will be -1. And then -2, and then -3. Are you good there? Don't be surprised to see possibly a matching problem or like a multiple choice problem in the AP exam like that. Now, what's different about number 3? I said we were going back to number 4. What's different about number 3? We've got x and y. So there's not really a real easy way about doing this. You just have to point to the spot and add them together. So help me as we go together. 0, 1, whoop, 1, 2. The point here is 0, -1. So if I add those together, I get -1. Add these together, I get -2. Now, you could try to look for some generalities here, but you might be best to just kind of pick a line and just continue to go. If I add these together, I'm going to get 1. 1, 1, I get 2. 1, 2, I get 3. Okay. And then here I have 1 and -1, which makes, oh, well, that's interesting. It looks like when they're opposite sign, you're going to get 0, right? So like if you wanted to start trying to knock some out, you could say, well, 2, -2, or -1, +1, or -2, +2. So if I'm grading this on the AP exam, I'm definitely looking for the zeros. Try to continue to finish here. So I'll continue to do this one. So I'm doing 2, 3, 4, 3, 4, 5.
Are you making them deeper?
Yeah. Then I gotta see 2 and -1, so that's gonna be a 1. So it's like those are all gonna be 1. Looks like that's gonna be 2. Back here I look like I've got a 1. Yeah, see, I have to think about all these, most of the time. -1, -1. Oh, looks like, actually I noticed kind of a pattern. Aren't the diagonals the same? Like, isn't that kind of the deal? Yeah, so you can kind of see a pattern here. You see the diagonals are the same. So I got -2, -2, -2, -2, -3, -4. Wow, that's really steep over there. Okay. You see that? So without a doubt, the idea is that we want to be able to see what's actually being, graded as you see the AP exam. So let's go to number 6. That one's really interesting. You got -y/x. We won't necessarily do all of these, but we got to get an idea here for what this is talking about. -y/x. First of all, if you divide by 0, what do you get? Undefined. So that means we have no slope fields wherever it would be undefined. So where is x0 on this thing? Right there, right? So therefore, I'll just put a little dot, reminding myself that I don't put a slope there. Okay? All right. So I'll do the slope fields in blue. Now, whenever y is 0, the whole slope will be 0, right? So where is y 0? Yep. So I'm going to go horizontal line here. All right. Now let's do some tricky thinking here, okay? I've got quadrants. I've got positive, positive. I've got negative, negative. And then I've got negative, positive. And I've got positive, negative. So as we think about these slope fields, tell me about the slopes in quadrant 1. They're all going to be negative because it's y divided by x and it's made negative. Do you see that? Yeah, you do. So if we take 1 divided by 1 and make it negative, we got a -1 there. And there's no good way of going about this. You just have to pick them. So how about this one? That's going to be a -2. How about this one? -0.5. And that would be a -1 there. -1/3. -2/3. Kind of tough to draw, huh? They're not going to be real critical on that, but can you understand that they're going to want to make sure that these are all negative? So that means that these will all be positive. So you could just do the y divided by the x and then make it positive. So 1/1 is going to be 1. 2/1 is going to be 2. 2/2 is going to be 1. It's going to be 1/2, 1/3, 2/3, whatever. Do you get the general idea? Okay, so I think you've seen enough introduction to slope fields. So this would be on the test. This would be like, say, 9 points, and there will be multiple parts of the 9 points. This would be worth about 2 points to get the slope field done correctly. Here's another thing that they would do on your slope field. They would say this, and I think this is kind of a cool question. Suppose here they would say that it went through the coordinate -1, -1. They would say draw a line that fits, or draw a curve that fits if it goes through -1, -1. So all you do is you would like go here and you put a coordinate -1, -1, and then you would just kind of draw the shape that would follow from there. See what I'm saying? You could do that, right? So those are the 2 basic things. Let's flip it over and figure out something else, okay? It says match the slope fields with their differential equations. So I just told you how to create them. Now you get the chance to match them. Don't be scared by sine of x. Start to just think about these and think about where would it be 0 or where would it be undefined. Go ahead and try to do the matching. Take about a minute and a half. Go. All right. Okay, what do you got? What do you got? There's one that should stand out here right away. What's the obvious one? I said A because I said if y is 2, then everything's 0, right? So like I looked here, I said y is 2, so like this is A. So I'm done there. X is 0. So like this one right here, a few ways you could think about it. Which one do you choose for 10? It's definitely B, and if you notice, if you were to take the antiderivative, you get x squared, right? Over 2, whatever. It doesn't matter. The idea is you get a quadratic. Totally fits, doesn't it? Yep. And you think about positives and negatives, all that stuff. X minus y is equal to 0. So I'm looking if I have like 3 minus 3. So I'm going to look for the point 3, 3. Over 3 and up 3. 0 there. I like that one. So this is definitely D. What's the antiderivative of sine? Negative cosine. So look at your curve. See how it makes a negative cosine graph? Tricky, tricky. You got that? See, isn't that cool? Yeah, it's kind of cool how you see it connect. Yeah, there's different ways to think about it. Try next one. Go. Then I do the dishes is what I do. I'm a pushover. Okay, which one was easy? Which one was easy? X plus y. Because if you looked, if they were opposite signs, they would be negative. So you chose A for that one, right? Got it. Sweet. I looked, if X is 2 here, then I get 0, right? If X is 2, then it produces 0. See that? And so here, X is 2, I get 0 there. So I say that guy is B. So I'm done there. Wherever y is 0, I get 0. So it's tough to tell the difference between these two. So I'm going to look, if y is positive, look at how y is positive up and y is negative down. So it's positive up, it's negative down. So all those slopes are going down, all these slopes are going up. So this is definitely graph C. And then I want to show you something kind of cool. If you were to sketch the solution here, what shape would it look like? A circle. And watch this. The equation for a circle, x squared plus y squared is equal to, say, whatever, we'll say 4. Remember the derivative of x squared? 2x. Remember the derivative of y squared? 2y. Y prime is equal to 0. And when we solve for y prime, we got 2y, y prime is equal to negative 2x. And you divide by 2y, and you get, look at that, y prime is negative x over y. So you see the solution to the circle, we've actually covered it before when we did implicit differentiation. There it is. Okay? All right, flip it over. You're ready for the next part. You guys are doing really good. Good job. Yeah, oh yeah. We want to use our time here. So, okay, f prime of x is your slope field. Okay, f prime of x is the slope field. F of x is the solution, or the graph that fits. So the question here is, the slope field from a certain differential equation is shown. So they're showing you this guy. which of the following could be the specific solution? So the specific solution is the graph that fits this. So does x squared fit that? No. What is e to the x? What does e to the x look like? Exponential functions look like that, remember? Yep. Does that fit? Definitely not. So it's not e to the x. Remember what e to the negative x looks like? Looks like that. Does that fit? Nope. Cosine graph. Remember what the natural log graph looks like? Starts down and it kind of turns up like that. Does that fit? Yeah, it sure does. It sure does. So in fact, y equals natural log of x. So if y is equal to the natural log of x, y equals natural log of x, if that's the particular solution, what's the derivative? What's the slope field? What's the derivative of natural log? 1 over x. Let's see if that fits here. Let's see if it fits kind of what we're doing. Look at the x value here. It's 3. Do all these slopes look like they're about 1/3? Yeah. Let's go like, like that might be, say, 1. That might be like 2. So 1 over 1. Do those all look like a slope of 1? Do those all look like a slope of about a half? Yeah, so see how it connects and fits together? That's pretty cool, okay? Look at the next one. It says a slope field for a certain differential equation is shown above. What could be the specific solution? So specific solution is the graph that fits. Go ahead, take 15 seconds, 20 seconds, see if you can come up with one that works. Make a guess. Go. Five, four, three, two, one. What'd you get? Yeah, very good. Sine doesn't fit. Cosine doesn't fit. X squared. Sometimes people choose x squared, but notice that those are going up, whereas your graph is going down. So it doesn't fit that half. This is definitely the solution for a cubic. And so we have 1/6 x to the third. Okay? Good. So we'll talk about the other piece on Monday. But right now what you want to do is you want to look at your worksheet. So let's pull out that worksheet. And your worksheet is the following, okay? You have 6 slope fields. You see these 6 slope fields? Okay. So you're going to sketch those, okay? Some of them are going to be easy. Number 6 is going to be more challenging. Do your best. And then what do you have on the next side? You have matching. Now, some of them might not be as obvious as others. So don't feel bad if you need to move on from one. You know what I mean? Like you might not be able to do them in order. You might got to pick one and move along. You would like to know the answers to these, and so I will post the answers. But I'll post them on Monday after you have a chance to kind of try them on your own. Okay? So that's that. You only have one topic left, and that's particular solutions to differential equations. And you'll be ready to test. So I see us testing at the latest Friday next week. Very latest. And after that point, you've covered all the calc material. And we're ready to review. So good job. After the AP test happens about a week later than we used to. And because we graduate early, the AP exam for this class takes place 10 days before you graduate. So you're going to have other AP tests by the time we build rockets, and then you guys will be, so I think it's the 10th that we have the AP exam, and I think your last day is the 17th or 18th or something. Is that right? So, and then you got the weekend in between there. So between the AP exam and your last day of school is like 4 days. So we'll build rockets and go outside and have fun and talk. And we'll calculate initial velocity and maximum height. Not really, but can we just pretend we did? Like, we gotta say we're doing something. Otherwise, people will be like, "Well, what's the educational thing you're doing?" You know? So we'll totally have fun and we'll build rockets. Okay, there's no like I mean, you guys have totally earned it. So, and you guys, I want this test to be an easy test. Like I want everybody to get 100%. So I could, but then I wouldn't be able to sleep at night. I'll live with it.